Hi guys, welcome to DOWLATH revision series, and for the next couple of weeks I'm going to be posting daily videos regarding application type questions. I'm going to start with basic topics of forces, thermal physics. I'll be also looking at some wave theory, and I'll be looking at Hooke's law and momentum as well. So let's begin with this question on forces, and what I'm doing is I am helping you guys, I'm teaching you guys how to approach the question. So in the first part, you have, firstly we go through the entire question and we try to take out the part of the question that provide information, and I call that concept apple picking. And then once you've identified what the variables are from the question, you can then tie it back into the theory. So let's go. So consider a 500-gram body. So the first thing is, what does this 500-gram body represent? This represents a mass. So M is 500 grams. Now, many times in physics, we like to work in SI unit. So our SI unit for 500 grams will be to convert it to kilograms, right? So the SI unit being kilograms. So I convert from grams to kilograms by dividing by 1,000. So my grams to kilograms, when I divide by 1,000, that gives me 0.5 kilograms. It's being pushed along a horizontal surface with a force of 25. So I have a forward force F1, which is 25 newtons, and it is experiencing a drag force of 10 newtons. Now, a drag force in physics is representative of a resistive force, right? Or a frictional force. And many of the times when you learn forces, the application of a frictional force is that it will oppose motion. So if you have a body being moved with a forward force, your drag force or frictional force will always oppose it. So our force of drag is 10 newtons. We can, if you want, label that F2 in the opposite direction. Determine the acceleration experienced by the body. So our question is asking us to determine A. So let's diagrammatically represent what the question is telling us. So we have a body. The mass of the body is 0.5 kilograms. It's acted upon by a forward force F1 being 25 newtons, and it is opposed by another force F2 being 10 newtons. Now, when you are asked to talk about acceleration, you must make the link to Newton's second law. Now, when we envision Newton's second law, we say in terms of an equation, F is equal to ma. So that force, that resultant force, is representative of the factor which causes the acceleration of a body. So from Newton's, I could go on to write here, from Newton's second law, my resultant force is ma. So if you wanted to show using a pyramid, right, we could basically determine A. So A is my resultant force over M. So how do we get our resultant force? Because we have our F1 is 25 and our F2 is 10. Now, when we talk about forces, they are examples of vector quantities. And a vector quantity has a magnitude as well as a direction. So what you will typically find is that we can now combine these two forces, these two separate forces, and because they act in opposite directions, you can combine them to show one single direction here. So if I consider this direction as positive, I have F1 minus F2, because F2, to convert it in one direction, I have to put a negative 10 in this direction. So it becomes 25 plus minus 10. That is the difference in the two, which gives me my resultant force being 50 newtons. So I now have 50 newtons divided by 0.5 kilograms. And that is going to give me the acceleration of my body, and that gives me 30 meters per second squared. So the question is pulling from your knowledge of Newton's second law, but it also asks you to identify what is the resultant force and appreciate the fact that it is the resultant force that causes the acceleration of a body. Okay? All right. So we are now going to look at another question that deals with momentum. Okay, so now we're going to look at momentum. So momentum, like force, represents a vector quantity, and more so, it is specifically defined as the product of mass and velocity. It is symbolized by P, and it is equal to mv. Now, we consider that you can have a relationship between resultant force and momentum. And I want you to understand that whilst we just established that it is the resultant force that produces the acceleration of a body, we are considering the resultant force to be linked to a change in momentum. So now let us create an equation to discuss the relationship between Newton's second law and momentum. So I am going to consider acceleration to be a change in velocity with time. So I'm saying that it is v minus u over t. Now you have to be acquainted with the symbols which are used in physics. U represents initial velocity. Initial velocity is what is the speed that my body is starting with. V represents my final velocity. What velocity after a time period t is my body attaining? So once my body, let's say you go from 5 meters per second to 10 meters per second over a period of 60 seconds or a minute, your body is accelerating. It undergoes a change in velocity with time. So what I'm doing is that I'm going to substitute for acceleration. I'm saying that it is v minus u over t. Now, if you are considering the equation for Newton's second law, where you say Fr is equal to ma, it is m open brackets v minus u over t is equal to mv minus mu over t. Now, this line in particular is pretty fundamental because what it establishes is the relationship between resultant force and momentum. Because now, by expanding the bracket, we have seen two expressions, mu and mv. The mu is representative of the initial momentum and mv of the final momentum. So now we could move on to this line where we could say the resultant force is the change in momentum over time. So delta p, delta is a Greek symbol, and it indicates change in momentum with time. Now let's apply it. Consider a ball of mass 300 grams. So again, I've identified this as mass. So that will be 0.3 kilograms. Right away, I have divided by 1,000 to convert it. Moving from rest. Now, let me elaborate on this a little bit. When we talk about rest, we're talking about an object which is stationary. And we use the term rest to establish that the velocity is 0 at that point. So if it's starting from rest, then my initial velocity will be u is 0. It then reaches a velocity of 10 meters per second, so v is equal to 10, and this would occur over a period t of 20 seconds. So I now want to determine the resultant force. So let's go back and use our equation. It is change in momentum over time. So that's mv minus mu all over t. And I could break it down to mv minus u over t. So my resultant force will be 0.3 by 10 minus 0 over 20. So 0.3 by 10 is 3. And 3 divided by 20 seconds is 0.15 newtons. So it's a pretty small force, but nonetheless, it allows us to establish fundamentals. So tomorrow, I've decided to do my lecture series as daily videos. So I am going to do some more application based, and we look at some challenging questions that are seen in different examining bodies. So join me tomorrow for another video.